Let's talk about OOP, or Object-Oriented Programming. Object-Oriented Programming is a popular programming paradigm. It's predicated on the notion that everything is an object. Object-oriented programming works with classes, which are abstractions of objects or entities in a problem domain. It also works with objects, which are instances of classes contained in a problem domain. OOP is supported by many modern programming languages like C#, C++, Java, JavaScript, Python, and many others. Object-oriented programming is enabled by four basic principles: abstraction, encapsulation, inheritance, and polymorphism. There are many key elements here, so let's talk about them in more detail. What is a problem domain? The problem domain defines a group of entities that computational systems care about. Entities are things that typically exist in real life. Entities will translate into computer code in the form of classes. For example, in a computational system used by an online store, typical entities will be product, customer, shipping address, purchase, payment. These entities will translate into classes that will be implemented by our system. Now, let's talk about classes. This is a very important concept. Classes are abstractions of objects. What that means is that they are an abstracted view of an entity. Classes are blueprints that define attributes and behavior of a given entity. Let's take, for example, a car class that will define attributes that cars have, such as color, make, model, owner, and so on. The class will also define that the behavior of cars involve accelerating, braking, opening trunk, turning on radio, blinking signal, and so on. Once we understand what classes are, it's easier to understand objects. Objects are instances of a class. They represent a specific specimen defined by a class. Building on the previous example, an object of type car belongs to the car class and therefore is blue, is made by BMW, is turbo, is model 2022, is owned by John Smith, and etc.